Yes, hello, good morning. This is SHENEY speaking.
Yes, good morning, Miss Dionyo. Sorry to trouble you, but I kinda have a pressing matter at hand, and I would like you to be my substitute for teaching the young, brilliant engineers studying in the College of Engineering University that our company has collaborated with.
Yes, ma'am. Yes, ma'am.
I know that you can do well since you are one of the best among the electrical engineers ranking. Anyway, your task is to explain the total values and individual values of two electrical circuits, the series parallel capacitor and the series parallel resistor. Would that be fine with you, Miss Jonyo?
It's okay, ma'am. I will do my best to teach the young, brilliant electrical engineers. Yes, ma'am. Yes, ma'am.
Okay, that would be great. Thank you. Bye.
Okay, ma'am. Thank you. Goodbye. So good day to you, future electrical engineers. I am Shani Junior, and today I'm going to discuss about the series parallel capacitor and the series parallel resistor. So first you're going to find the series parallel capacitor, and here is our circuit. So we have C1 is equal to 4.1 farad, C2 is equal to 1.6 farad, C3 is equal to 6 farad, and C4 is equal to 6 farad, and we have 20 voltage. So we're going to write that down here in our table. So we have the C1, C2, C3, and C4. So the first thing that we are going to find is the C total. But we have a problem. Since C2 and C3 is parallel, so we are going to first find their answer. So, using the formula, we have C2, we're going to combine C2 and plus C3. We have C1, 1.6 farad plus 6 farad. And our answer, using the calculator, we will be able to get 7.6 farad. So, since we already have the answer for C2, we can then proceed in finding for the C total. So using the formula, we have 1 over C1 plus 1 over C23 plus 1 over C4 times negative 1. We're going to write their value. And then we have 1 over 4.1 farad plus 1 over 7.6 farad and 1 over 6 farad times negative 1. Using the calculator, we will be able to get an answer of 1.845 farad. So now we have our C total. So the next thing we were going to find is the Q total. So we have the formula of QT is equals to CT times VT. I'm going to put their value. And we have 1.845 farad times 20 voltage. And using the calculator, we will be able to get an answer of 36.9 voltage. So, since here in our circuit, C1 and C4 is series, so our Q total in the formula of Q, in finding for the Q or the source charge, Q1, Q2, Q3, and Q4 is equal. So whatever the answer of Q total is, so that's also the value or the answer of Q1, Q2, and Q3, and Q4. But since Q2 and Q3 are parallel to each other, so Q1 and Q4 and Q total have the same answer, but Q2 and Q3 have different answers. So since we already have Q1, so here we have Q1, Q4, and Q total rather. So they have the same value, or they have the same column or answer. So we're going to find for the Q2 and Q3. But before that, we're going to first find for the voltage, because we can't find the answer or value of Q2 and Q3 because our formula is C times V, and we do not have the voltage. So that's why we're going to find for the voltage first. So let's find for the V1. So V1, we have the formula V1 equals to Q1 over C1, and put down their value. We have 36.9 coulomb over 4.1 farad, and using the calculator, we'll be able to get an answer of 9 voltage. So we have V1 is equals to 9 voltage, and then we're going to write that down in our table. Next, we're going to find for the V23. So since V2 and V3 are parallel to each other, so we're going to combine them. So we have V23 is equals to Q23 over C23, and putting their value, we have still 36.9 coulomb over 7.6 farad. So we have 36.9 coulomb here because that is in the first place, series pa man sila. So if in writing the table here in the source charge, their first value is 36.9 coulomb. That is their first value for Q2 and Q3. But since they're parallel, so that's why we're going to find for their exact answer. So first, in their first value, so that's what we're going to use here in the Q23. So since they are parallel to each other, so they have the same 36.9. So 36.9 coulomb. Using the calculator, we'll be able to get an answer of 4.855 voltage. And since V2 and V3 are parallel to each other, so now in putting down in the table, we will also write the same value for V2 and V3. We have 6.15 voltage here because using the formula again, 36.9 coulomb over 6 farad, we have 6. Using the calculator, you'll be able to get an answer of 6.15 voltage. So next, we're going to find for the Q2 and the Q3. So first, they are now, we are going to find their individual value now. They are not combined with each other. Din sila Q2, 3, because we already have the value of V1, V2, V3. So, using the formula, C2, Q2 equals C2 times V2, and put down their value, we have 1.6 farad times 4.855 voltage, and using the calculator, we'll be able to get an answer of 7.768 coulomb. And now we're going to find for the Q3. So the same formula, Q3 is equal to C3 times V3, and putting down their value, we have 6 farad times 4.855 voltage, and using the calculator, we'll be able to get an answer of 29.13 coulomb. So now, this is our series parallel capacitor. So this is now a complete answer for the series parallel capacitor. So now let's move to the series parallel resistor. So this is our series parallel resistor circuit. So we have R1 is equals to 100 ohms, R2 is equals to 90 ohms, R3 is equals to 45 ohms, R4 is equals to 180 ohms, and our voltage is 24. So we are going to write that down in our table here. We have R1, R2, R3, R4, and our V total. So first we're going to find for the R total. But like what we have did in the series parallel capacitor, if it is kanang combination siya or the parallel ang R1 and R2, so we are going to first find for the R12. So using the formula, we have 1 over R1 plus 1 over R2 times negative 1, and put down the given value. We have 1 over 100 ohms plus 1 over 90 ohms times negative 1. We have, using the calculator, we will get an answer of 47.368 ohms. So we're going to find for the R34 next. So using the same formula, we have 1 over R3 plus 1 over R4 times negative 1. We have, put the given first, the value first. So we have 1 over 45 ohms plus 1 over 180 ohms times negative 1. And using the calculator, we will be able to get an answer of 36 ohms. So our R34 is 36 ohm, and while our R12 is 47.368 ohms. So now we can then find our R total. So our R total is the combination of R12 plus R34, and put down their given value. We have 47.368 ohms plus 36 ohms, and using the calculator, we will be able to get an answer of 83.368 ohms. So now we have our R total, so we are going to put that down in our table. Next, we are going to find for our I total. So using the formula, we have I total is equals to V total over R total, and put down their given value. We have 24V, so because our total voltage is 24V over 83.368 ohms, and using the calculator, we'll be able to get an answer of 0.288 amp. So we're going to write that down here. We have 0.288 amps. So we don't have this similar answer for the I1, I2, I3, and I4 because I12 and I34 are parallel to each other. So, since they are parallel to each other, we can't proceed to them first because we are going to find for the voltage, because the formula for our current, or our I, is V over R. And since our voltage is not yet given, so we are going to find for the voltage first. So we have, first we have V12, so we have the combination of, or the parallel capacitor of V12 equals I12 rather. I12 times R12, and put down their value, we have 0.288 amp times 47.368 ohms. So, like I said earlier in the series parallel capacitor, the value of V1, V2, V3, V4, their first value is 0.288 amps because that is the law of the series. So, but since they are parallel, so we're going to find for the exact answer. So, now we're using the calculator, we'll be able to get an answer of, if we multiply them both, we have 13.642 voltage. And since V1 and V2 are parallel to each other, so in putting down the table, they have the same value. So 13.642 for both V1 and V2. Next, we're going to find for the V34. So the same formula, we have V34 is equals to I34 times R34, and putting down their given value, we have 0.288 amp times 36 ohms, and using the calculator, we'll be able to get an answer of 10.368 voltage. So now we have the value for V34, and like V12, since they are V34 are parallel to each other, V1 and V3 and V4 rather, since they are parallel to each other, so they have the same value or answer. So V3 and V4 have the same answer, which is 10.368 voltage. We can now proceed. So now we can proceed to finding the current, or the I1, I2, I3, and I4. And since the voltage and the resistance is already given, so in finding or looking or calculating for the answer of I1, I2, I3, and I4, so we're going to solve them individually. So now we have our formula. I1 is equal to V1 over R1, and putting down their value, we have 13.642 voltage over 100 ohms, since V1 is equal to 13.642 voltage, and our R1 is 100 ohms. And using the calculator, we'll be able to get an answer of 0.136 amp. Next, we're going to use for the I2. You're going to find for the I2. So the same formula, we have V2 over R2, and putting down their value, we have 13.642 voltage over 90 ohms. And using the calculator, we'll be able to get an answer of 0.152 amp. And next, I3 is equal to V3 over R3, and putting down their value, we have 10.368 voltage over 45 ohms. And using the calculator, we'll be able to get an answer of 0.230 amp. Next, for the I4, we have V4 over R4 rather, and putting down their given value, we have 10.368 voltage over 180 ohms, and using the calculator, we'll be able to get an answer of 0.058 amp. So now we have our I1, I2, I3, and and I4. Now let's proceed in calculating for our power. So the formula for power is P equals V over I. So P1, so in solving for the power, let's solve it individually. So P1 is equals to V1 times I1, and putting down their value, we have 13.642 voltage times 0.136 amp, and using the calculator, we'll be able to get an answer of 1.855 watts. It's watts. And next we have the P2. It's not covered, I'm sorry. So since they have the same formula, the same step in finding for the answer, so multiply them. 13.642 voltage times 0.152 amps. So using the calculator, we'll be able to get an answer of 2.074 watts. And next, we're going to solve for the P3, the same formula again. P3 is equals to V3 times I3, and putting down their value, we have 10.368 voltage times 0.230 amp is equals to, using the calculator, we have 2.385 watts. Next, we have the P4. So P4 is equals to V4 times I4, and putting down their value, we have 10.368 voltage times 0.058 amp, and using the calculator, we'll be able to get an answer of 0.601 watts. Next, let's solve for the P total. So, in solving for the P total, we will use the same formula. So, P total equals V total times I total, and putting down their value, we have 24V times 0.288 amp. And using the calculator, we'll be able to get an answer of 6.912 watts. So, here is our solution for the series parallel resistor. Watching this video, and I hope that you'll be able to understand both the series parallel capacitor and the series parallel resistor. Just wait for our video call, and I'll be able to ask you about your understandings or insights about the discussion of today. Thank you. Bye. So good morning to the both of you, future electrical engineers. It's a pity that today's current situation doesn't allow us to meet physically, but on the other hand, it is not completely out of hope, because I have assigned you all to watch the video about series parallel capacitor and the series parallel resistor. I have assigned that 2 days before today, as far as I remember. So now I'm going to ask you, what have you learned in this topic, and does it spark your interest in becoming an electrical engineer just like me? Yes, Miss Goldie, would you like to share your insights?
Yes, Miss. I have learned that due to electric potential energy, electrons move from one point to another. Thus, electric potential energy can be transferred to electrons through work done. Normally, electrons move to any direction. If this flow is regulated and made to move continuously in one direction, then the flow becomes an electric current. And the limitations to series parallel capacitor, where the source, charge, voltage, and capacitance is asked, I'd be able to know the capacitors in a circuit. And this is what excites me more. So after this session, I will further study about this topic. So thank you, Miss, for teaching this to us. That would be all.
So you have learned a lot from this topic. So how about you, Rinzel? Do you have any opinion about this topic?
We have the same answer, ma'am.
Are you sure?
Yes.
So thank you, young engineers, for participating in this call. May you learn a lot from this topic and be motivated every day. Thank you. Goodbye.
Goodbye, Miss.
Goodbye. Goodbye, Miss Goldie. Goodbye, Miss Rizal.